Hey guys, so for today we're going to do a little bit of practice from Chapter 9. This is for Chem 101 students. We're going to practice naming just simple organic compounds. We're not talking about anything with any kind of functional groups on it. We're just talking about hydrocarbons, just hydrocarbons. So you will be given this little bit below here where meth is 1, eth is 2, 3 is prop. Now what are these numbers? What are these prefixes? These are the number of carbons that you have. So determine the number of carbons, and that's the first part. The second thing that we're going to need to know is the ending. So if you are an alkane, you end in ane, you're going to have the formula of CnH2n plus 2. So if you're alkane, so any kind of alkanes, those are the propanes, methane, butane, right? So if you end in ene, you have the formula CnH2n, right? So however many carbons you have twice as many hydrogens. And if you have the ending of yne, Y-N-E, you have the formula of CnH2n minus 2. So let's put this into practice. So this is the endings, right? The endings to the word. And then these are basically the prefixes. These are the prefixes. Or suffixes and prefixes if you go back to, English. So for this one, how I would start naming this compound is I would say 1, 2, 3. So I have 3 carbons. So I know that it's going to be prop something. So it's 3 carbons. So it's going to be prop something. So propane, propene, or propine. Those are my options. Now, let's talk about how many hydrogens we have. We have 3, 4, 5, 6, 7, 8. So I have 8 carbons. So the formula is C3H8, right? So what formula does this follow? Are the H's twice the N's plus 2? Yes, right? Because H is 2 times 3 plus 2, right? So since 8 equals 2 times 3 plus 2, we know it must be an ane. So the formula here is propane. So, well, let me get another color going on. I think it does help when we have some barriers here. Nice and divided. Okay. The next one is already in, see, for this one we had to put it into this format, right? The very condensed format. We're going to go ahead and just apply that here right now. C3H6. So what formula, we know C3, so we're going to have to be using, again, we're going to be having a prop something, so it's prop something. So is it propane, propene, or propine? Let's figure it out. This follows the formula of CnH2n, correct? Because there are there's only twice as many H's. So this follows the formula of CnH2n, so it must be ene as the ending. So this is propene. Next, down here we have 4 carbons and 10 hydrogens. So this has 4 carbons, so we would be given this, and it's bute something. So it's butene, butine, or butane. So it'd be bute something, right? Because we have 4 carbons. Now is it butene, butine, or butane? Let's figure it out. 4, this is twice as many hydrogens, or sorry, this is it follows the formula of CnH 2n plus 2. Hopefully you can see that. Because 4 times 2 is not enough, you'd have to add 2. So it follows this formula. It just so happens that CnH2 plus 2, or 2n plus 2 is ane. So this is the formula for butane. Here, we'll turn this into a very, very condensed formula, this CnHN formula. This is going to be C2H6, correct? So this again follows the Cn of H2 plus n, right? Because 2 times this would be 4 and then plus 2. So we know that it's going to end in ane. And since it only has 2 carbons, that's F. So this is ethane. C6H10. C6, we know that our prefix is going to be hex, so it's going to be hex something. Now is it hexane, hexene, or hexyne? Let's figure it out. C6, if I were to double that 10 is not enough, right? So H must be equal to 2n minus 2, right? So this is hexyne. You could think of it as if n is 6, right? Hopefully this is all coming clear. If n is 6, if we multiplied 6 times 2 and then minus 2, what would we get? So 6 times 2 is 10 minus 2, or so 6 times 2 is 12 minus 2 is 10. So C6H10, it fits the yne requirement. So it's hexyne. Lastly, we have C7H14. C7 looks like we're going to be starting with hept something. And then we have, what is the relationship between the number of carbons and hydrogens? Is it times 2? Is it times 2 plus 2? Is it times 2 minus 2? The relationship here is it's just times 2. So that fits this description for ene. Cn and H 2 times n, right? In this case, n is equal to 7. So this is equal to 2 times 7. So this must be heptene. This is about as challenging as I'm going to make it on the exam. So as long as you're good with these practice problems and good with the homework, then you should be good to go.